Alright, so on to homework 13, over the mean, median, and mode, and what it means to have a skewed data set. So, homework 13, this is problem number 2. Problem number 1 will follow these same lines. So what we're given here is some data values, and from these data values we would like to find the mean, median, and mode for these values. Okay, so the mean is the sum of the values divided by the number of values that you have. So to find the mean, we would take 53 plus 52. So here's my calculator. 53 plus 52 plus 75 plus 61 plus 68, 60, 47, 47. Which gives us a sum of 463, which we need to divide by the number of values we have. So that'd be 1, 2, 3, 4, 5, 6, 7, 8 values. And we're told to round to the nearest tenth as needed. So 57.875 rounded to the nearest tenth would be 57.9. All right. The median is the middle value, so we would have to sort these values from smallest to largest and then find the middle value. So at this point, I want to show you something, and if you click on this little box, you can open these values in Excel. So there's our values in Excel. And if you hit enable editing, we can tell Excel to calculate something for us. So click in an empty cell and hit equals and tell it you want this cell to equal the median, left parenthesis, and highlight the values you want to take the median of, or find the median, and 56.5. So round to the nearest tenth as needed. What did we say it was? 56.5. All right. So also recognize that we could have Excel calculate the average for us. So if we wanted Excel to calculate the average, click in an empty cell and hit equals, average, left parenthesis, highlight the values you want to take the average of, right parenthesis, enter. And there's our 57.875. Rounded to the nearest tenth is 57.9. The last thing we want to find for this data value set is the mode. So the mode is the most occurring value. So looking through these values, 47 showed up twice. No other numbers showed up more than once, so 47 is going to be the mode. But let's have Excel verify that for us. So we'll hit equals mode, left parenthesis, highlight the values you want to find the mode of, and there's our 47. So recognize if you click on this little box, you can open up the values you see in Excel, and then you can use these preloaded functions in Excel to find the average, you can find the median, and you can find the mode. So again, the mean is commonly thought of as the average. The median is the middle value of your data set. Recognize you need to have your data set sorted in order to find this median. Additionally, the mode is the most occurring value. All right, so the mean, median, and mode make up a large chunk of this assignment. The last part that we really have to pin down is the idea of a skewed data set. So let me draw us a picture. There we go, focus. Okay, so to understand a skewed data set, that's supposed to go straight down, what a symmetric data set is. So this would be a symmetric data set. It's symmetric about this middle. This middle is where your mean equals your median equals your mode. So if your mean, median, and mode are all the same value, what you would find is a nice symmetric distribution. Now, a symmetric distribution is not guaranteed because, as we just saw, there's no reason why a mean should equal median should equal the mode. However, this is a frequent occurrence, which we will explore in the next homework. But for now, recognize that the median does not have to equal the mean, and it does not have to equal the mode. However, when that does occur, we get this nice symmetric distribution. So, to be a skewed distribution, or to have a skewed data set, means you are not symmetric. And what we would find is, say, this curve represented test scores, and say you had a number of students that missed a test. Consequently, they get zeros. So consider the instance where you would have more values showing up on this lower end of the distribution than normal. And what that would do to your distribution is it would essentially take this curve and pull it more towards the left. So when we have more points showing up on the low end of the distribution, we would get a distribution that seems to have been pulled towards the left. So let me draw us another picture. We'd have something like this. And due to more values showing up on the low end of the distribution, that is going to take our mean, our average, and it's going to pull it towards the left. The most occurring value would still be at the peak of this distribution. So this would be our mode. And then the median is going to fall somewhere in between the mean and the mode. So when we have a distribution where the mean is to the left of the mode, this would be considered left skewed. So when you have mean to the left of the mode, or when you have the mean to the left of the median and mode, we have a left skewed data set, or a left skewed distribution. And similarly, you can say this for a right skewed distribution. So right skewed, here's our distribution. It would look something like this. And we'd have more values building up on the right of our distribution, or on the upper end of our distribution. So this peak is still going to be the most occurring value, which would be the mode. And due to this buildup on the high end of the distribution, that is going to take my mean, my average, and pull it towards the right. So we would see a mean to the right of my most occurring value, and in between the mean and the mode, somewhere will live the median. So this would be a right skew. So recognize, to determine if a distribution is left or right skewed, it really comes down to comparing the mean to the median or the mode. So let's take a look at what we have for problem 10. We study 200 random families. Results are summarized as the mean family income was 47,000. So the mean, the average, was 47,000. The median, the middle value, is 30,000. The highest and lowest incomes were 250,000 and 2,500 respectively. So from that information, we want to choose what distribution best fits our data. So recognize, the mean is 47,000. The median is 30,000. So we do have the mean sitting to the right of the median. So because we have the mean sitting to the right of the median, that tells us it's a right skewed data set. A right skewed data set would be C, and I know you're probably thinking it's B. However, it's not B, it's C, because you can envision taking a nice symmetric distribution, and to have a right skewed set, essentially you grab this tail and bring it towards the right, which would give you this shape here. So, moment of truth. All right, so recognize the shape of the distribution might be not what you anticipate. So recognize a right skewed distribution looks like most of the data sits on the left side of the distribution, where a left skewed distribution appears as if most of the data is sitting on the right. So however, keep in mind a better way to conceptualize left skew and right skew is a left skew has a mean to the left of the median and mode. A right skew has a mean to the right of the median and mode. All right. Is that it? No. All right. Describe the distribution as symmetric, left skewed, or right skewed. Choose the correct answer below. Well, that's how we determined it was C. We told ourselves, well, that's a right skewed set, or a right skewed distribution, because the mean was to the right of the median. How many families in the sample earned less than 30,000? Explain how you know. Choose the correct answer below. So 30,000. What is the 30,000? Well, that 30,000 was the median. So that's your middle. So if 30,000 is in the middle, that means half your data sits below, and then half your data sits above. So half of our data is going to sit below 30,000. Half of the data is going to sit above 30,000. Well, we studied 200 families, so that must mean 100 families make less than 30,000. 100 families make more than 30,000. So how many families in the sample earn less than 30,000? 30,000. That would be 100 families. Based on the given data, can you determine how many families earn more than 47,000? Why or why not? Well, the 47,000 was the mean, or the average. So 47,000, based on the data given, can you determine how many families earned more than 47,000? So A, no, because the number of families that earn more than 47,000 depends on the distribution. Or B, yes, because the mean is the middle value in the sorted data set. Well, the mean is not the middle value in the sorted data set, so there's your red herring. A is the correct answer. Which makes sense. I mean, you can't determine how many more families earned more than the 47,000. You can for the 30,000, and that's because the 30,000 was the middle. So you know 50% is above and 50% is below. All right. And that completes the lesson for homework 13. Thanks for your attention. I'll see you on the next one.